Good day, students. I want to take you once again on physics. But today we are looking at moment of force and equilibrium. Specific objective. At the end of the lesson, you should be able to define moment of force about a point, state the effect of moment, define a couple and state the effect, then state the laws of equilibrium, solve problems involving moments and equilibrium. Okay. Now we say that a force, we know already that a force can make a body to accelerate. So whenever a body is acted upon by a force, it is either the body will accelerate, rotate, or turn about a point. You know, a body can turn without rotation. So in this case, we say the turning effect of the body is called the moment of the force. Now the turning effect produced depend on the magnitude of the force and its distance from the pivot. So now, you know, the pivot, you know, is also called the fulcrum. That is the point whereby the action of the forces starts. So therefore, we define moment of force about a point as the product of the force and the perpendicular distance from a point to the line of the action of the force. Again, we say moment of force is the product of force and the perpendicular distance of each line of an action about a point. That point we are talking about is the pivot. So hence we say a moment of force is equal to force multiplied by the perpendicular distance from the pivot. Now, couple. Couple is another type of moment. In this case, you know, sometimes a system of forces can cause a body to undergo rotation and will not produce any linear motion. Such a system is called a couple. Okay, consider something like a situation whereby you are turning a water tap. When you are turning a water tap, or you are riding a bicycle, or the action of a corkscrew. In these situations, you consider that you apply two forces in opposite directions. The two forces must be parallel to each other. But you will notice that the two forces, they are not acting along the same line. So that means their line of an action do not intersect. So such forces are called couple. For instance, when you want to ride a bicycle, you discover your both legs will be applying the forces on the pedal. When one apply a downward force, it now produces an upward force on the second leg. You notice that the two forces are parallel to each other. So we call such forces a couple. So we define a couple as a system of two equal and opposite parallel forces not acting along the same line. So I've given you examples of couple. So we say the effect of couple is that it produces rotation of the body it is acting on. So any body that is acted upon by a couple, the body will undergo rotation. Now, we say the moment of couple is the product of one of the forces and the perpendicular distance between the two forces. Again, the moment of the couple is the product of one force and the perpendicular distance between the two forces. Okay, now we'll now look at resultant and equilibrant. We say a resultant of forces is a single force which produces the same effect as a system of two or more forces acting together. It produces the same effect as a system of two or more forces acting together. That is what we call the resultant of a system of forces. Now, equilibrant. Equilibrant is a single force which keeps in equilibrium a system of two or more forces acting together. For instance, you consider a horizontal beam resting on a pivot, and there are two or more loads on one side of the beam. If a single load is placed at the other side such that it balances the beam horizontally, that single load is called an equilibrant. So there are cases. We have the example of equilibrant in something like seesaw system, where you see many people sitting on one side and a single person sits on the other side will balance the other people, making sure that the system remain in equilibrium. Is an example of equilibrant. Now we look at what we call the law of moment or principle of moment. The principle of moment states that when a body is in equilibrium, under the action of several forces, the total clockwise moment is equal to the total anti-clockwise moment. I state again, when a body is in equilibrium under the action of several forces, the total clockwise moment is equal to the total anti-clockwise moment. The SI unit of moment of force is in Newton per meter. Newton per meter. Example, you consider a uniform rod of negligible mass and balances when a weight of 3 Newton is placed at A, then weight of 3 Newton is placed at B, and a weight W is placed at C. What is the value of the weight W? Now we represent the system in a diagram. You see that the uniform rod is pivoted at the center as shown in the diagram. You see that one end A is the place where the force of 3 Newton is acting. Then You have a point B, another 3 Newton is acting, and that B is 1 meter from the pivot, while W is acting at the other end, C. Now we apply the principle of moment. You remember, the principle of moment states that the clockwise moment is equal to the anti-clockwise moment. And you remember, we say moment is the product of the force and the perpendicular distance. So we take the moment of the point about O. O is the pivot or the focal. Now, you look at the anti-clockwise moment, you see that there are two forces acting on the left hand side, and the two forces will be responsible for the anti-clockwise moment. So the force 3 Newton at A multiplied by its perpendicular distance, which is 3 meter. So that is 3 multiplied by 3 plus the second 3 Newton acting at B multiplied by its perpendicular distance, which is 1 meter. So we have 3 multiplied by 3 plus 3 multiplied by 1, giving us 3 times 1 plus 3 times 3, giving us 12 Newton meter. That is the anti-clockwise moment. Then on the other side, you see W produces the clockwise moment, which is given by W multiplied by 3, which is 3W. So we say clockwise moment is equal to anti-clockwise moment. So 3W is equal to 12. That means the W is equal to 4 Newton. So always know that the moment of force is measured in Newton meter. Always make sure you convert all the quantities to their SI units. Is very much important. Example 2. The following bar is of negligible weight. Determine the value of X if the bar is in equilibrium under the action of the forces shown below. So when you look at the bar, now we are not told the length of the bar. We just see that the bar is pivoted at a given point, and we have a system of forces acting on the bar. We have 10 Newton acting at a distance of 60 cm from the left, 10 Newton acting at a distance of 20 cm from the left, and 15 Newton acting at a distance of X cm from the right, then 5 Newton acting at a distance of X plus 20 cm from the left. Okay, now we consider the diagram and look at the solution. The clockwise moment, as we see, the clockwise moment will give us 15 Newton multiplied by X plus 5 Newton multiplied by X plus 20, as we have in the diagram. Then the anti-clockwise moment is equal to 20 multiplied by 10. You see it? That 20 represents the distance of the 10 Newton from the pivot plus 10 Newton multiplied by 60, giving us 800 Newton centimeter. Remember, we are supposed to convert, but because finally in the left hand side and in the right hand side both distances are measured in cm, they will cancel out later. So now we said the anti-clockwise moment is equal to the clockwise moment. So 800 Newton cm is equal to 15x plus 5x plus 100. So that means 20x plus 100 is equal to 800. That means 20x is equal to 700. then x is equal to 35 cm. So therefore the length of the bar is going to be 40 plus 20 plus 35 plus 20, giving us 115 centimeter. So we see the value of x is 35 cm, while the length of the bar is 115 centimeter. Now, equilibrium and center of gravity. The center of gravity is usually denoted by CG. We say is the point of balance of a body in which the total weight of the body seems to act through. We can also define the center of gravity simply as a point where the resultant weight of a body acts. So for any regular shape, any regular geometric shape, the center of gravity is always at the middle. For example, a uniform meter rule, I use the word uniform. A uniform meter rule, the center of gravity is always at the 50 cm mark. A uniform rod or any uniform beam, the center of gravity is at the middle of the rod or the beam. For a rectangular object, the center of gravity is the point of intersection of the diagonals. For a triangle, the center of gravity is the point of intersection of the median. But you know, when we have non-uniform object or non-uniform beam, we note that the center of gravity will never be at the middle. So the center of gravity is determined by the geometric size of that beam. So we now say that for irregular bodies, each weight still acts at the center of gravity, and a lot of moments can be used to determine the weight of such bodies. Okay, example. We have example on center of gravity here. So you look at the figure below, it shows a uniform bar. The weight of the bar is denoted by W and the length is 80 centimeter. Now, if a force of 20 Newton keeps it in equilibrium, then you are to determine the weight of the bar. Firstly, you draw the diagram, you know that the weight acts on at the center of gravity, which is at the middle of the beam. Since it is a uniform bar. So it's uniform. So the weight is acting at the center of gravity, and the center of gravity is at the middle, which is the what? 40 cm mark from both ends. So you see that the pivot is located at 50 cm mark from the left. So you also make use of the principle of moment. So you now see that the 20 cm mark will now be acting from at 30 cm from the pivot, while the weight will act at 10 cm from the pivot. So we now say we take the moment of the force. So the clockwise moment will be the weight multiplied by 10, giving us 10 W Newton centimeter, while the anti-clockwise moment will be 20 multiplied by 30, giving us 600 Newton centimeter. So we say clockwise moment is equal to anti-clockwise moment. Therefore, 10 W is equal to 600. Therefore, W is equal to 60 Newton. And that gives us the weight of the beam. Okay. Now, parallel forces and equilibrium. You know, we now talk about the condition for the equilibrium of a system when it is acted upon by a system of parallel forces. We say for a body to be in equilibrium, You know, when we say a body is in equilibrium, it is neither moving nor rotating. So, when a body is in equilibrium under the action of parallel forces, the following conditions must be satisfied. Number one, the sum of the forces acting upward must be equal to the sum of the forces acting downward. In other words, we can say the total upward forces is equal to the total downward forces. We can also put it in this way: the algebraic sum of all the parallel forces acting about any direction must be equal to 0. But remember, when we talk about this, we must know that we can assign the upward forces to be positive, while the downward forces will be negative. Number two, the sum of the clockwise moments must be equal to the sum of anti-clockwise moments. In other words, we can say the algebraic sum of the moment of force about any point must be equal to 0. Also, take note that in this case, we can assign clockwise moments to be positive, while anti-clockwise moments will be negative. Then we now say the first two conditions must be what? Be fulfilled for the body to be in equilibrium. So we say that they are the condition for the equilibrium of parallel forces acting on a body. So this is something you must take note. It is an examination question. They will ask you to state the condition for equilibrium of a system acted upon by a system of parallel forces. You see that we have two conditions. Number one, the total upward forces must be equal to the total downward forces. Number two, the total clockwise moment must be equal to the total anti-clockwise moment. Okay, summary. We say the moment of a force about a point is the product of force and the perpendicular distance of the force about its line of action from a point. Then we now say again that the effect of the moment of force is that it produces the turning effect on the body. We also say that when a body is acted upon by several forces, then the algebraic sum of the moments, the clockwise moment must be equal to the anti-clockwise moment. So, then the assignment. So you see the question, then you submit on a Google Classroom. So, if you have any question, you prepare it and forward it to me, the Google Classroom, or you bring it when we have our Zoom class. Thank you very much and stay safe.